Our team was tasked with finding creative solutions to everyday problems faced by those with autism or who are nonverbal. After researching the many difficulties they face, we decided to focus our efforts on two areas: decision-making and speed of communication. Our initial design included an app that offered a decision tree-based UI where users would select different options based on context. We quickly realized that it would still take too long to communicate, and the trees could easily expand beyond a reasonable scope. The solution was a system of instant communication that lets users quickly and easily make decisions. We call it VoiceBox. When the user opens the app, they are immediately greeted with a live camera view. We wanted the design to be easy to understand and as simple as possible. Instead of decision trees, users can point the camera to what they want, say a certain fruit, and we use image recognition to immediately display the object's name. To communicate, the user can tap on the object and the device will use voice technology to say the object out loud, essentially giving the user a voice.
Orange.
When they tap on the object, they will be offered two choices. The first is love it. If they choose an item that they use often or like to eat, say an orange, they can tap on the love it option and it will be saved to a favorites list, which we also call the love it list. The other option is try it, which are items they just want to communicate at that moment but don't necessarily want to keep it on their love it list. Opening the love it list is a simple tap. The list is populated on a database server so that users won't lose their lists if they change devices. When users click love it, they aren't only saving the name of the object to the list. VoiceBox takes a photo of the object, and that image is also displayed along with the name. This gives them a visual reference, along with a textual reference of an object. We found this important in helping with communication, but we also discovered this could be a powerful tool for speech therapists and helping those with autism or who are nonverbal, or even those who have difficulty making connections between an object and its correct name. You can click on these options and the text-to-speech will also say the name.
I want orange.
Well, we started really early in the process, and that gave us enough time to go through several iterations. And then after speaking with Anthony, our director, we realized that we need to really focus, really narrow our focus. And fortunately, all of the layers were in place. So when it came time to reworking it, we were able to knock it out pretty quickly.
My process was taking the wireframes that Marie gave us and figuring out how to properly convert them into Swift. I tried to make it as simplified as possible. Anything that I saw that seemed maybe a little overcomplicated, I tried to break it down so it was easier to access for a wider audience.
We're using a machine learning model, and specifically ResNet 50 that we found off of Apple's developer site. It's a pre-built model. We're using Apple Vision to actually recognize the image, and when it finds an object in that model, then it displays a button that changes the label to the object that it says. So you point at a banana, it'll change the label on the button to a banana. In the future, what we would do is build our own model. That gives us more control over what objects are added to the model, and it would also allow us to recognize multiple objects at once, which is kind of our ultimate goal.
I just used the native AV foundations that's built into iOS and Swift as a programming language, and this just uses the Siri voice that everyone's already used to, so it's pretty easy to implement.
Banana.
Really, it was just a balancing act of trying to make sure it worked well with our visual recognition and our saying choices from the database we have set up. So once we got that communication figured out, it worked like a dream.
We're using a Firebase database to keep users' data synced up and keeps it saved in the cloud in case anything goes wrong with their device. And we don't need to do a full update to the app every time we add new data or make changes to the data. We can just do them right on the Firebase backend. When the image recognition recognizes an image, you have the option to save the image and add it to a favorites, which saves the image and then uploads it to Firebase's storage, where then it stores like the pathway to the image in the Firebase storage, so you can then retrieve the image back and display it back to the user.